In this video, I'm going to show you how to create a reaction simulation. Here you have barium ions and sulfate ions, which do form a precipitate. So we've got two precipitates formed. These two ions still have yet to meet. When they do, they'll end up at the bottom of the scene. So I'm starting with my working copy. This should look familiar to you. So the way I have it, both sphere 1 and sphere 2 move, but nothing happens if they bump into each other. So let's now edit the prefabs. Sphere 1. Now I'm going to rename it so that it looks like an ion. Label for sphere 1. Over here on the right is where you get to input your text, but we're going to be a little fancy here and use HTML tags. So let's make this just like I had in my video, BA, and it's +2. So I'm doing Control S. You can see it updates the text, but it's not a superscript. So go back to this text box here. Superscript is coded by SUP, sub, inside these brackets. But then you need to also do end sub, which is a slash with the sub in brackets. That's HTML code tags, and it will make the +2 a superscript. Let's see that. Control S, and now you can see it looks beautiful. Sphere 2 is going to be the sulfate. So first I'm finding the prefab, double click, find the label. So here I want to do SO4, but the 4 is a subscript. Bracket SUB is for subscript. The 4 is going to be a subscript. End subscript. So it's the slash and then the sub again. Save that. And you can see I have SO subscript 4. Now I want to make a superscript for the charge. Sup SUP for superscript. -2 for the charge. End superscript. Save that. And now we've got sulfate labeled with a subscript and a charge as a superscript. It's beautiful. So now I need to add the reaction capability to one of the prefabs. So I'll do sphere 1. Sphere 1. On the right, add component. It'll be a script. And intuitively, I hope it's the reaction script. You can see here that there's a space to say other reactant tag and a space for products to instantiate. Right now the list is empty. So first, when these two meet, when the barium and the sulfate meet, the prefab we want to instantiate is going to be the sphere pair prefab. So first I'll click this plus here. You could have multiple products instantiated. That's why it's products, and you could have a list. In this case, I just want one. So I'll drag this sphere pair bonded. Sphere pair bonded. I dragged it into the slot. Products to instantiate. So that means when the reaction happens, a sphere pair will appear. The other thing we need to do now is to say, well, when does the reaction occur? This script is attached to sphere 1. The other reactant tag happens to be sphere 2. You have to type this in exactly. It's sphere 2, capital S, no space. And let me show you why that works. So here on the sphere 2 prefab, if you look up at the top, it has a tag which is sphere 2. So the script will be looking to see when sphere 1 collides with something, did it collide with the actual target for the reaction. That is the meaning of this other reactant tag. If sphere 1 collides with sphere 1, we don't want a reaction to happen. If sphere 1 collides with sphere 2, we do want a reaction to happen and instantiate the pair of spheres at that time. Going to try to see if this does function. Over here I'm going to click on this console. This will give me messages. Sometimes it tells me errors. Sometimes it gives me useful information. Click play. Let's see what happens when sphere 1 meets sphere 2. And you can see there was a sound. I did get a sphere pair that are bonded. They're not labeled. This green and blue sphere are not labeled, so you probably want to label them. You can see in my console it did say reaction occurs. Yay. If I want the sphere pair to have a label, let's look at the prefab. There is a space for label of sphere 1. There is a space for label of sphere 2 in the bonded pair. Right now those are both blank. So the easiest way to do this is to go back to the beautiful label you already made. So I'm getting to sphere 1 prefab, the one we gave the barium +2 with the superscript. You can just highlight, copy, Control C, go back to the sphere pair bonded prefab and paste in that. Same thing for sphere 2. I've already labeled sphere 2 when it's alone as sulfate. Highlight, copy, go to the bonded pair, find sphere 2, paste, Control S. And now let's take a look in the scene view at the bonded sphere pair. That looks gorgeous. Okay, go back to game. Run it now and see if it looks right. Boom! There we go. So in your simulation, it's likely that the precipitate is really bouncy. So clearly we don't want that. So what we need to do, the bottom wall, so here's walls, expand it if needed, find the lower wall, by default is quite bouncy. So go over here to the right and you'll see box collider material, and it has a bounce 1.0. So you need to change that to something less bouncy. I recommend bounce 0.6. And now if we try this same scene, so there you see, instead of bouncing infinitely, it sits there on the bottom like it should. Okay, again, that was lower wall box collider material. These are called physics material. They're not colors, they're bounciness and friction. To make this more useful, I think we should populate the scene. Scene view. Let's drag in some extra sphere 1s, some extra sphere 2s. You can clearly illustrate the concept of an excess reagent here. You also get the idea of concentration matters when determining reaction rate. Let's try this. So there's the ion pairs have found each other. The excess reagent, the excess sulfate, still bouncing around and will do so forever. To beautify the scene, to give it some more context, in the user interface controls, there's a water background that you can activate with the empty checkbox here on the upper right. So that may give things better context that this is happening in an aqueous environment. You can also, if you like, add other user interfaces. So probably for temperature to be important here, they're moving too fast in the beginning. So if you recall, we can change the speed, the relative speed of the particles, maybe make them quite slow. This is sphere 1. This is sphere 2. And now it may actually, a student might actually be able to see that temperature can play a role in reaction rates. Yeah, look at how slow things are now. And if we increase the temperature, things get a lot faster. With the mechanistic, not just temperature makes things go faster because, I don't know, but the rate at which the ions will find each other increases. All right, have fun with that. So you've made this sphere 1 be the barium ion. There it is. It's got the label, it's got the reaction script. It's possible that you want to save this prefab as barium ion. So this is optional, but if you want to do it, highlight sphere 1, Control D to duplicate. That'll give you the second copy of sphere 1, and then call this BA +2 ion. And then it will be there for you in the future. So you could imagine having an entire library of prefabs of various ions or atoms, so you wouldn't have to remake them each time.